A student of mass 63 kilograms falls freely from rest and strikes the ground. During the collision with the ground, he comes to rest in a time of 0.04 seconds. The average force exerted on him by the ground is 18,000 newtons, where the upward direction is taken to be the positive direction. From what height did the student fall? Assume that only force acting on him during the collision was that to the ground. So starting off, we have mass is 63 kilograms. We have velocity initial is 0 meters per second. We have time is 0.04 seconds. We have force is 18,000 newtons. And we have to find the distance from which the student fell. Now to do this, we're going to have to find the final velocity of the student right before he hit the ground. To do this, we're going to use the impulse equation. Now, I don't know if you remember in one of my earlier videos, I told you that impulse can either be force times change in time, or mass times change in velocity. So if we equal those two things off, since they're equal to each other, we can make an equation, which is right there. Force times change in time equals mass times change in velocity. So we plug in the numbers, 18,000 times 0.04 equals 63 times velocity, and that's how we're going to find our final velocity. Simple algebra, you solve it, and you get 11.43 meters per second is our final velocity. And now, I'm sure you already know kinematics. We're going to use a kinematics equation to solve this. This one right here. And then, I forgot to tell you guys, the acceleration in this system is negative 9.81 meters per second squared. That's the acceleration due to gravity. Since he's falling, gravity is what's accelerating him. So just plug in all those numbers and you'll get the distance, which is x. 6.65 meters. That's the answer.